Welcome to Brain Vision.
In both situations, we are going to use the following reference frame. This axis will be the y-axis, and this will be the x-axis. Now we can apply Newton's second law on both directions. So for situation number 1, applying Newton's second law on the y-axis gives us the following. The net force in this direction is given by the mass of the rider and the bicycle times their acceleration in that direction. Note that the bike is not going to move upwards like this or downwards like this. Then its acceleration in that direction is equal to 0. So the net force in the y direction is equal to 0. And the net force is composed by two forces in this direction. We have the normal force, which is pointing to the positive y direction, so the normal force, and we also have a component of the weight force, which is pointing to the negative y direction. Let me call this W component y. So the normal force minus the weight component y should be equals to 0. Then the normal force is equals to the y component of the weight force. Now for the x-axis we have the following. On the x direction, the net force is equals to the combined mass times the acceleration in the x direction. Note that in this situation, the bicycle is going downhill with a constant velocity. So its acceleration is equals to 0 in the x direction. Then the net force in the x direction is equals to 0. But the net force in the x direction is composed by two forces. The air resistance, which points to the negative x direction, and the x component of the weight force, which points to the positive x direction. Then the weight force component x minus the air resistance force is equals to 0. So the air resistance force is equals to the weight component x. Now, in situation number 2, we are interested in calculating this force, which is the applied force that is necessary for the bicycle to go uphill. Then we should apply Newton's second law here first in the x direction. So the net force in the x direction is equal to the mass of the bicycle times its acceleration in the x direction. Again, it's going uphill with a constant velocity, so its acceleration in the x direction is equal to 0. Then the net force in the x direction is again equal to 0. Now the net force in the x direction is composed by three forces: the applied force, the air resistance force, and the x component of the weight force, which we can draw as follows. So this would be the x component of the weight force, and this would be its y component. Then the net force in the x direction can be written as follows. So pointing to the positive x direction, we have the air resistance force and the weight component x. And then pointing to the negative x direction, we have the applied force. And this whole thing should be equal to 0. Then the applied force should be equal to the air resistance force plus the weight force component x. But note that from situation number 1, we discovered that the weight component x is equals to the air resistance force. Then the applied force should be equals to the weight component x plus the weight component x. Then the applied force is equals to 2 times the weight component x. Now, how can we calculate the x component of the weight force? We have to take a look at this triangle. So we have 90 degrees here and 50 degrees there. So why this is 50 degrees? Well, you can note that this angle here should be, if this is 15 degrees, it should be 75 degrees. Now we can extend the weight force, and this makes a 90-degree angle with the ground. And then this is a triangle, so its internal angles should add up to 180. And we have 90 here, 75 here, and 15 here. 75 plus 15 is equals to 90. Then, in fact, this triangle has internal angles that add up to 180. Therefore, this angle is really 15 degrees. Then, we can use the sine of 15 degrees to calculate the weight component x. because of the sine of 15 degrees. In this context, will be given by the opposite side of the triangle, which is the weight component x, divided by the hypotenuse, which is the weight. Then the weight component x is equal to the weight times the sine of 15 degrees. So the applied force should be equal to 2 times the weight times the sine of 15 degrees. But the weight force, remember, is given by the mass times the acceleration of gravity, which is approximately 9.8 meters per second squared. And the mass, the combined mass, is 80 kilograms. Therefore, the applied force is given by 2 times 80 times 9.8 times the sine of 15 degrees. And this results in an applied force of approximately 406 newtons.